We're about 5 minutes after. I see all the usual folks are here. Let's go ahead and get started. I suspect Nell may not join us as she's in the process of packing and moving.
Oh my, that's exciting.
Very exciting. So skipping the intros because we all know each other here. I recognize everybody. And it's a little small group, so maybe we can have today be kind of a casual discussion amongst all the folks here. Feel free to popcorn ideas, add to the agenda. Frederick, I see you on chat rather than voice. If you are around a little bit later in the meeting, it sounds like, I'd love to hear an update on GitBOM Go then, or whenever it works for you in the schedule. Yeah, what would folks like to dive into? David.
So we've been swirling around some of the issues related to metadata, and I realize this is more spec oriented than tech oriented, but we've been talking a lot about the metadata. We've been talking a lot about kind of having a tree, and we've been focused mostly on kind of the leaf nodes in the tree. And I'm wondering if we can start exploring what kind of how we build the tree and what kind of data we would want as augmentation to, hey, here's the hash of the entity. So the entity might be a source file, or it might be an intermediate representation in the case of TypeScript to JavaScript, or it might be a, .o file, or whatever linkers put together for executables or shared libraries. So does anybody have any thoughts on additional kinds of metadata that we would want to capture?
Yeah, I have one that may help clarify this discussion. As I've been framing the work we're doing to internal groups at Microsoft, it dawned on me that we might have two specs coming out. One part of it that we haven't really called out yet is the intermediate, the format of intermediary data passed between build steps that is needed to build the next stage in the graph. And that may be, I think it's all sort of the auxiliary data. It's not part of the hash in a given file, but it's essential to build that you pass on more information than just what is contained in the, say, the GitBOM header in the inputs to an intermediate step. So Bharati, you might have seen some of this with LD. My understanding here is after you've built the first, say, object file, and your next step, you're building, you're linking multiple object files together, you can't do that just from the headers in the object files. You actually need the hashes of the source files. You need the whole GitBOM document for those object files, right?
Yes, that's right.
Okay, so we need an intermediate data format as well, some way to propagate it.
You have the, so when you have a list of, when you have a set of objects that you're linking to build a shared object or an executable, so you expect that if that object was built using a GitBOM enabled toolchain, you're going to have the .bomb section in it, right? So you need the object as a complete entity, and you're going to go and inspect the .bomb section. So these are the two things that you care for building a GitBOM enabled, a GitBOM shared object or an executable. So if that object file, say, was not built using a GitBOM enabled toolchain, you're not going to have the .bomb section. So you will just leave it out when building the entry for that object. So essentially, the linker, what it is trying to look for is the object which it anyway has access to, because otherwise you will not be linking it. The only thing that may or may not be present is the .bomb section within the shared object that it is accessing, or the object file that is being used for the link. A shared object can come in by way of dependency. What you might access a shared object as a part of satisfying some dependency during link. So those are the two things.
Okay, so just thinking about that and going up a level, the Docker folks are looking at increasing the semantic richness of Docker files. So rather than simply being effectively execution scripts, they're looking at building some semantic richness. So as you're thinking about, okay, we build a shared library, and let's say that shared library would be then packaged as a Debian file, and it would be, you know, dpackage installed, or RPM, or whatever your packaging system is installed. How do you then propagate the information that you've collected from the linker process up into the Debian file? And then how can we start associating that information with a layer in a Docker file?
I think all the tools involved will need to have this support, right? Because right now the support is available only up to creating the .so or the binary. So the level above. Yeah, go ahead.
No, please finish.
Yeah, that's what I was saying. Archives or whatever auxiliary tools are used after the objects are built, I think they also will have to have support for propagating this information up the chain.
Yeah, I think this gets sort of the thing you were talking. I think what you were talking about, Eva, originally about intermediate steps is I've been sort of conceptualizing it in my mind as, how do you aggregate together and pass along not the actual not the receipts, not the outside, not the police box, but the inside of the TARDIS. How do you pass that along as you go? Because, you know, the original sort of very naive thought was you write out the .bomb directory, or whatever we could end up calling it, into the same directory where you're writing out the artifact. And then that, of course, gives you sort of a scatter-gather problem where you've got to go and collect these all together, even for a simple build, in order to pull together the actual tree that you want to move forward through whatever means. And that's just within a file system. And so then the next step that you're sort of getting to, Dave, is how do you then pass this on from there as well, right? So how do I pass this on if I'm a Debian package? Do I pass this on? How do I pass this on? So for example, one of the things the Debian packages solved really early on that was kind of interesting is the issue around licenses documents and being able to have those in common so they're shared between multiple packages. Because it's probable that you don't have to bring the whole tree when you install a Debian package. You just have to bring the next piece because the previous packages that you depend on had brought their pieces of the tree. And then, of course, what does this look like in a world where we're shaving every freaking byte off a container we can? Because the bigger your containers are, the longer it takes for your cloud native applications to converge. And so, like, you know, if you're picking up a lot of heft there, you probably don't want to, and inevitably someone's going to want to trim that out. So I guess that's kind of how I was conceptualizing the problem.
Yeah.
Okay, so this is a great framing of the problem, and I'm going to go to Jeff now and say, Jeff, you know, at Cisco, you're going to be responsible for putting together documents or thingies that are presented to customers for the contents of a box. And, you know, like the firewall boxes run multiple Docker containers, they have some native code, blah, blah, blah. And, you know, I got to assume the routers are pretty much the same thing. If there's a cloud native service. You know, at what point is there going to be an SBOM requirement for the cloud native service? What kind of information are you going to need bubbled up so that you can present all of the relevant information about the contents of either a device or a service to Cisco's customers?
Yeah, it's an interesting question, and the timing of it is interesting as well. When we look at this from that perspective of like, how complete should the supply chain be? Of course, we want turtles all the way down, right? But we're not going to solve for that today. So actually, the way that I listened to Bharati talk about it, I thought, okay, but if you can't go and access that GitBOM document in that repo or wherever we might store it, at the very least, you should be able to use the Git hashing algorithm to create one of the shared object that you're going to reference, because you have that byte array. And at that point in time, you can now start a new, I guess this would be a new leaf node of that tree, right? And then perhaps we can work backwards at a later point in time. But we have to assume that it's always going to be incomplete. We're never going to have perfect information.
I 100% agree that, you know, in this case, this is a perfect is the enemy of the good. And, you know, we can say that, you know, look, in year one, we're going to, you know, shoot for 70% coverage. And, you know, this gets back to Bharati's point about tooling, which is, look, we're not going to have all the tooling. And the tooling is not going to all be in place. And quite frankly, a lot of the tooling that is used to build systems might be 2, 3, 4, 5 years old. Nobody's going to go upgrade it next week just because.
Or 20.
So,
so you know,
yeah.
the SPDX community right now is spinning up an effort around how do we generate these documents from a build. And so this build profile working group is having conversations, and I'm part of them, but I would love if any of you have interest to join those meetings, because they're having the same discussions. And I think where we have an opportunity is to highlight which parts of this should be embedded in and traveling with the build itself, and which parts of this are metadata that you can resolve back to the build artifact, right? I think that's the real place that GitBOM complements something like SPDX. And I think that there's this natural tendency to say, okay, well, we should be able to generate an SPDX style file or an SPDX document for every snippet and every file and every package all the way through that system, whether it's the actual build or it's the put all that into a tarball, or it's, you know, whatever step you are in that process. And I think this is where we can really lean into that conversation and say, hey, here's the part that GitBOM can help with, so that we can then, maybe we need to just do some after the fact linking of other types of metadata and made the point of licensing or for the security use case or whatever else that is contained in that SPDX document. So
if I could make a suggestion, right? This is just like two thoughts that occur to me, just as incremental movements forward from where we are right now. Because where we are right now is we're essentially dealing with where you're writing the artifacts to, and that's where we're dropping the .bomb directory. And so you wind up with a fair bit of scattering. It feels like there are two available improvements that could be made here. The first improvement would be to allow for some kind of a well-known environment variable that points to where your GitBOM .bomb directory is, as far as you're concerned. And if the build tool is run and it finds that environment variable, it should respect it. The second that we might want to consider drawing from is, in the absence of any of such an environment variable, you can sort of do what Git does and walk up the directory tree to see if you find a .bomb directory along the way up that looks like it is in fact a GitBOM .bomb directory. If you find one up tree from you, then that's where you actually write out your GitBOM documents to. I'm just kind of curious folks' thoughts. Those are not necessarily the perfect answer, but I feel like they're incremental improvements on what we're doing right now.
Before we sort of dive into those two, I want to sort of double check, it does sound like we are all in agreement that having a consistent way to propagate this intermediate data, the GitBOM documents of each build step to the next build step and potentially other information about that build step, like compiler flags. We need to have some consistent way to propagate that between build steps and build tools. And I think there's an easy example to visualize for me to go from a C library to a Python library built into an RPM or Debian package, which is then installed in a Docker image. At each step, there's a great amount of loss because the tools of each one of those don't understand the typical outputs of the steps before it. And yet that final Docker image, if the GitBOM document published with it terminates at the preceding layer, it's very incomplete, right? So that's an easy way to communicate this idea to others who aren't on this call. Also, hello, welcome, Jeremy. We're deep in something right now, so you can walk it back.
I suspect it's something that Jeremy has opinions on, because yes, Jeremy has interesting cases where the file system as a means of propagation is not your best choice. So
I would love to finish the hypothesis I was just proposing, and then we can unwind it for Jeremy.
Really quickly though, I think it's consistent within a particular kind of domain. So for example, if I am a build tool, like if I'm a C compiler compiling it out of file, a linker linking it, then I'm a Python piece rolling this together into a PyPy module, etc. These are all sort of file system oriented build tools. And as file system oriented build tools, saying here's how you go find your .bomb directory is a very nice, consistent way of going about it. It tells you sort of where to write things and where you might find other information. But when you start getting to things like building Docker containers, where Docker's whole mode of operation is to say, I'm going to have a context that lives entirely within the directory for context you gave me. So it's down directory of the context you gave me. And I'm going to copy that context into the Docker server where we're going to do things to proceed with our build. Or I'm going to get some of that information from a layered file system that I'm pulling in from a base layer. There's a little bit of a hop there that is going to be slightly different than just tools living in a common file system. Does that make sense?
So that makes tremendous sense to me. And what you're describing, I think, requires an abstraction that we should be working on for the Rust and the Go and whatever other GitBOM tools we build, which is the where do you read and where do you write abstractions. So if you basically say, look, I want to read, I want information on a particular hash, or I want the tree for a particular hash, I want the node for a particular hash, whatever. These should be queryable, but they should be interfaces so that we can re-implement them, as server-based thingies or as file system-based thingies, whatever. But I think, it might be a good conversation across me, now, maybe a few others on the tech side, as to how we create an interface around that. Does that make sense, Ed? Does that satisfy kind of the both file system and non-file system oriented stuff?
Maybe. So I'd have to think a little bit more on the Docker container, and I suspect Jeremy has other useful examples that we'll want to look at as well.
I'm going to reassert my question. I guess, Jeremy, have you by now picked up the full context here, or would it be helpful for me to reassert my question and give you the backstory?
I had been looking for a little while before I unlocked, so I have some context here. I think, actually, why don't you repeat your question, because I just to remind me exactly what it is you're asking.
So the thread is discussing what sound like two different requirements. There's the GitBOM, embedding the hash in the binaries. We've all agreed that merely having the GitBOM document hash in a given artifact, an intermediate artifact, is insufficient for the next stage in a build process to build a complete tree. If that stage built a tree, it would terminate at the incoming artifact's fingerprint. And so I gave the analogy of a C build toolchain that outputs a library linked into Python, which is then built into a Debian image, which is then installed in Docker. And if each of those four tool chains, at its termination, only the binary artifact is propagated, including a BOM header, the next build step can only refer back to that input if it doesn't have the entire tree somewhere. So we need a consistent format or mechanism for propagating the entire tree between these different build stages and ecosystems. And that is roughly where we got to Ed pointing out that, yes, but file system is only one of the means of doing so. He proposed we might have two different ways for file systems, the default of a well-known env variable pointing to where it is, and in that absence, walk up the directory tree looking for a well-known directory name like Git does. I think that's about when you joined, because we also need some other mechanism besides file-based, which, you know, on the technology side, yes, we do. On the specification side, we'll have to come up with how would we write into a spec that encompasses file and non-file based.
So what occurred to me as I was listening to this was it might be useful to frame a ideal, not necessarily technically feasible, but an absolute ideal of what we would like there to be. Like, and then we can decide what the properties of that thing are and what's the best approximation of those properties that we can achieve. And so if you imagine that it's like a BOM cloud where there is a great big pool of every single GitBOM document that has ever existed, possibly that ever will exist, and you can just query it and you will get back all the details you need. And then if that document refers to other things, then you can recursively query until you run out of stuff. And so like any kind of file system based thing is going to be a very small approximation of that. But like for one, does that actually encompass, like if we had that, would that solve all the problems, or are there other problems that you would need to deal with? And I have another point. David, why don't you talk? Because I have another point that's related to this, but is a little bit more controversial, I think.
So I have a adjacent project that I've been noodling on called BombSage, which is a mechanism for publishing the trees out to a publicly queryable system. But one of the prerequisites is there are basically validator nodes that have to validate the publication, because if you publish garbage, or there's a poisoning attack where garbage can be published and there can be a problem. So what you need is a level of validation of the tree information. So I think that having a globally queryable Merkle tree, in other words, here's my hash, give me the inside of the TARDIS for this hash, that makes perfect sense, but I don't think that can be published during build time. So maybe there's an internal system where you publish intermediate artifacts that are then bundled up and sent out to the global system. But I don't think that we could have a global queryable system that would run in real time with a build. Does that make sense?
Why not?
Well, so I mean, the point I see from that is that these tools are not trustworthy. We just because the Go compiler said that it consumed these inputs and produced this output, we don't actually have any idea about whether those were actually the inputs it used, or did it just make some stuff up, or did it pick some files from somewhere else, or whatever. And so like this kind of gets back to the point, next point I was going to get to adjacently, which is the only real way of verifying these Git bombs is by reproducing the build. And so you have to have enough detail to be able to do that. But I think there's what strikes me as a bit of sloppy terminology here, which is conflating GitBOM documents with build steps, because a GitBOM document as currently specified is just a set of inputs, and any two processes that have the same inputs will share the same GitBOM document. So that is not sufficient to even slightly approximate a build step, because for a build step, you have to know what was done to those things and also what the outputs were. And so right now, the way that GitBOM is specified, the only way you can tell what the outputs of a set of inputs is that you have another GitBOM document that references a GitBOM document, like another GitBOM document that references an artifact, comma, input document tuple. And then that's your only indication that that artifact was an output of that set of inputs.
And a point of clarity, Jeremy, in the original drafting Ed and I did last year, that is the artifact itself, right? So the artifact is a self-contained assertion of what its inputs were. There's no separate document that says this artifact and this build tree came, like, they're related. The artifact itself contains the relationship to the build tree. I agree with you in principle, totally on board. Just the clarification that there isn't a separate document because it's embedded in the artifact.
Yeah, so I think I do want to sort of get to a couple quick things from what Jeremy was just saying. So the first thing I think, Jeremy, is that in the spirit of you saying, in an idealized, possibly unachievable world, what would we want? I would say that in that same sort of fiat world, you could just posit that you can trust, for whatever reason, your GitBOM document store, right? Because there are real issues around with the trustworthiness, but as you pointed out, they're broader and bigger. And if you're just trying to figure out what would the characteristics of the store look like, something where you could go and query or recursively query these things. I feel that's more in the spirit of where you were originally going. Am I correct there?
Yeah, I mean, in the same way that even if you're talking about, there's always just a /tomp/bomb that everyone can write their documents to. You still can't trust those either, because anyone can write. And like each individual document, you could verify that its bits are correctly formed, because you can rehash you can fetch the inputs and rehash them and produce the same document output. But you still can't verify the compilation steps.
We are completing several things. I think you're right on that. As far as fiats for trust, we have long had assertions of trustworthiness via certificate authorities and things like that, which, of course, something being built by Microsoft or Google doesn't necessitate that it's flawless or should be trusted by some other entity. It's just a declaration like anything else. I think we've all seen the reproducible build work that folks are doing to be able to publish multiple attestations of sort of a verification to say, I built with these inputs, this environment, these flags, and I got this output. I'm going to sign that and publish that. And then if you do the same thing and someone else does the same thing, we get 3 or multiple data points published claiming the same thing. It's unlikely that all those claimants are colluding.
Right.
And that could increase trust in it. That only works for things which are reproducible, which is not nearly enough yet.
But it gets a bit more back to the scientific method, which is, why do we trust the speed of light? Because lots of people have independently come to relatively close measurements.
Yeah. So,
actually, no.
So while having a framework that enables independent parties to publish an attestation or claim of some reproduced build is good, and that helps, it is not a thing we can base everything on. It's simply not achievable today.
Yeah, so I think the trust aspect is not one that I want to focus on right now. I think I still don't understand exactly what you mean by I don't quite understand what you meant by that clarification earlier, Ava, about the artifact as the thing itself. Is it like you have a BOM document which represents a set of inputs and its identity is computed from that set of inputs, and then
the BOM document's identity is computed from the inputs that are stored in the BOM document.
Right. And some of those inputs are to leaf artifacts, so they're just direct artifact references. And other inputs are references to other GitBOM documents as a tuple, which is a artifact ID and a GitBOM document ID. And that's your indication that that previous input document did in fact have a particular output.
I think that might be the gap. I believe those are not references to the artifact ID, GitBOM ID tuple, but rather just to the GitBOM document ID of the preceding steps.
I think actually what Jeremy is getting to is if you look at a line for a derived artifact, it's BOM space something, which is a reference to the artifact that's the input, space, it's blob space something, reference to the artifact input, BOM space something, which is the identity of the inputs to the artifact that itself is the input here. And I think that's what he means by being a tuple of the input artifact and the input artifacts inputs.
Right.
Is that correct, Jeremy? Did I capture what you were suggesting?
Yes.
Okay. And I think what Ava was starting to get at is you're sort of saying, you were saying, look, all you really have here is the inputs in the GitBOM document, and then you reference it by the tuple of the artifact and the artifact's GitBOM document when you want to reference, a derived artifact. And I think one of the points Ava was making, which may relate to sort of what you're getting to, is in that sort of final step out into the world, when you get to your final artifact, whatever it is, you've got the GitBOM document, which is the inputs, and you have the artifact itself into which you've embedded the ID for that GitBOM document as part of that chain process there. But I think your underlying point is that you would have the same inputs for different outputs, correct?
Right. If you didn't record the output artifact ID at all, then if you had multiple processes using the same sets of inputs, they would be completely indistinguishable from each other. You'd have no idea about what outputs you are actually looking at, let alone what processes generated those outputs. So in the current design, what outputs a particular set of inputs is capable of generating is sort of inferred by the fact that someone is using that output. Like you could have a step that produced outputs that no one's consuming, and then they're not referenced at all, which is fine because irrelevant outputs are not relevant. But it does mean that it's very hard. Like in the current design, it's very hard to actually reverse engineer, even if you had the complete set of GitBOM documents, what the build process actually was. And so like you could have a separate concept of a build step, which is a combination of a GitBOM document describing a set of inputs, plus a set of compiler options and, toolchain identifiers and all that sort of stuff, and a set of outputs that build step produced. And then that would be, in a sense, a more complete thing.
David, I see your hand. I want to wrap this in one small term. Ed, I think Jeremy is right. Our singularity property is flawed.
Could you say more?
As framed, it's the singularity property is the tuple of all. An artifact should have precisely one dependency graph. All equivalent artifacts have the same dependency graph. But the corollary, many artifacts can be built from the same dependency graph.
So I would sort of say it differently, which is that there is a natural place that the mind goes from the singularity principle as currently stated, which is to desire it to be the case that a dependency graph has precisely one output. And that you are absolutely correct, and Jeremy, I think, has made this point several times, but this is absolutely not true. But there's a directionality to the singularity claim. It is one set of claims to say that for a given artifact, there's precisely one artifact dependency graph, and all equivalent artifacts have the same artifact dependency graph. That goes one direction. It goes down the tree. It's an entirely different thing to say that for a given tree, there is precisely one thing up the tree from it. And I don't see this so much as intrinsically a flaw in our artifact singularity statement, artifact dependency graph singularity statement, because that's made with great precision. I would easily be persuaded that it is a desirable characteristic to have the upflowing version of this. That's an easy thing to persuade me of. But I think, as stated, we are actually still correct in the artifact dependency graph statement, which actually reminds me really quickly, since we've got the right set of people here, how do people feel about artifact dependency graph as a term of art?
That seems like a good phrase. I don't know what up and down means exactly.
Yeah, I think, Ed, I was barely able to follow you with the up and down references there. And I think you use them the opposite of how I use them in conversation.
But I think since you've raised the singularity thing, so my understanding of what that singularity property states is that you're not allowed to have convergent build processes, that you are not allowed to have two separate independent dependency graphs that happen to produce the same set of bits as an output. Like that would violate the singularity principle. And that seems really overly strong to me.
So what it was trying to get at is the problem that we have right now in the SBOM world, where two precisely identical build processes producing precisely identical outputs can have an unbounded number of SBOMs.
But I think that's just intrinsic to the problem, right? Because you can state in your makefile that you depend on all of these input files, and then those input files could actually have no contribution to your output. And so you can have an arbitrary number of makefiles that produce the same output just because they happen.
I'm expressing a stronger concern. I can take precisely the same build process with precisely the same inputs. I can run it and produce a set of bytes. You can run it and produce exactly the same set of bytes with exactly the same output. And SBOMs will capture, there is an unbounded number of SBOMs that can be used to represent that, because SBOMs include metadata that is fuzzy.
So I have just found other flaws in our singularity principle, but I do see David's hand up for a while, and he's been so patient.
So a couple of things. The first one of which, I talked to some folks in the Scala world, and one of the assertions is the Scala compiler is multi-threaded. And you can have exactly the same input, and depending on the scheduling of threads, you can actually generate different class files.
So that's just evil. We should fix it the same way.
It's non-deterministic is what you're telling me.
Yes. So, but I think the important concept here, at least in my mind, is that we have a DAG. It's an acyclic graph of, ultimately, if our vision is borne out, we have an acyclic graph of the universe of all software that was produced after a particular date, or substantially all the software that was produced after a particular date. The interesting thing is, what nodes are nodes that could lead to vulnerabilities? What nodes are nodes that could lead to concern? And the fact that you have those nodes that, using Edwards, going up the graph rather than down the graph, in other words, from a shared node going up, you have to ask the question, where does it go up to? So even if you have non-reproducible bytes that come out of a build, if those non-reproducible bytes point to the same DAG, the information that we care about, which is this software potentially vulnerable to particular exploits? That is one of the core questions that we want to be able to answer. And we still get that even if we have seven different collections of bytes for the same input using Scala C. And I have to be careful because can't piss off the Scala people in a public forum too much.
I saw Frederick and then Jeff.
So part of the way that I think of this is the build process, how you arrive to the creation of those bits. Even though from a technical perspective, we may not often care, from a business and human context, we care very deeply, because the process is an important aspect of the inputs that lead to determining whether or not I want to trust some given output. So if you have multiple independent, on one side, if you have multiple independent processes that lead to the same output, the input GitBOM should be different there. You'll end up with a different output GitBOM for the same Gitoid that was generated, and I think that that's okay, because we represented the set of inputs that went into the process differently, even if they both output the same thing. Now, when it comes to something on the flip side of it, on the output of this particular system, having that ability to analyze and to be able to tell that a particular system is, or a different set of inputs is present from a value perspective, I think is hugely important. So I think in this scenario, we should consider even the process. Like, even if I decide to run the same set of inputs and we end up with something that's not deterministic, that non-deterministic output is part of the input of whatever is next. So I think we end up capturing that, even if there's some chaos in the process. And of course, best case scenario, people will converge. But I think it's something that we could possibly live with as the compilers over time continue to make efforts, heroic efforts, to get to build reproducibility. But at the end of the day, the process allows me to determine, even with that randomness that's built into the system, whether I want to trust that particular binary or not, even if it's not reproducible.
I mean, that means that you need to have trust in that build step, that the build step is a good faith that output is a good faith representation of those inputs.
That's correct. But that being said, that doesn't mean it has to be 100% trust. Like, I trust Microsoft to do a best effort to build Windows, and if I receive bits from Windows that has gone through this process, I will trust it enough because of the business relationships and prior history there. So that where it comes from, we're not going to get 100% trust. But the question is, based on that gap, is it, am I willing to accept the risk of that particular information being incorrect based upon the source of that information? And that may not be 100%, but the answer is often yes, we're willing to accept that risk because of these reasons, and we do so on a regular basis. So this moves the needle in a positive direction, even if it doesn't 100% solve the problem mathematically.
So as I listen, I wonder what we might want to consider is, how do we more clearly articulate what GitBOM is meant to do and is not meant to do? I mean, I feel like we're talking about provenance and how you're taking an action on that build, or what actions you're taking, as opposed to what are the inputs and what are the outputs. And I don't know that GitBOM solves all of this. And I think we should be focusing some of this conversation on which parts can GitBOM solve and which parts can other metadata in a structured format like SBOM or structured format like Salsa start to solve for. And I think the more that we can have that conversation and show each, because across the industry, supply chain security, people are talking about this, right? The more that we can articulate where and how GitBOM can help with those other parts of the discussion, the provenance, et cetera, the more worthwhile I think it'll be. The second point I have is that this upstream, up and down is interesting because we're thinking like upstream in the supply chain versus up the DAG perhaps. And I think we should be very clear in the way that we all talk about this. We're talking upstream in the supply chain or up the DAG because they're inverse.
My DAGs go left to right.
There you go.
My DAGs are 4-dimensional. I can't represent them on paper. So.
Only 4, Jeff? 5, 6? How many dimensions can we get to a DAG here?
Oh, I seem to recall there are actually theorems about the maximum number of dimensions are not necessary to represent graphs, but I don't remember them off the top of my head.
Frederick, I didn't quite capture your description of provenance, but I think you raised a really good point there, that GitBOM is not a stand-in for the trustworthiness of a given claim.
Correct, and part of that I use for that type of information is going to be things like, has the who built it? This is where the things like the SBOM come in. Is that like who built it? What was the process? Like I want in toto attestations to tell me what the process was. Maybe in some extreme cases, I may need some form of code signing to have occurred to say that this developer, even without the name of the developer, because I actually don't think that should be a part of it, but that the person there was working under all of the additional controls that that may be required for that particular product, or in order to validate that the workstation of the developer is not being compromised in the creation of this work. So ideally we don't have to do that.
So many hands just went up, and I want to point out that the question of, and Jeremy, I think you framed it well. If I understood correctly, your question was, how does GitBOM fit into the overall landscape of supply chain security? How does it complement or work with signing, build tool verification, hardware identity, trust systems, all of that? Where does it fit in, and what does it solve for that those don't? Was that what you were pointing at? I want to just make sure I understood your question so that we can go work on it. Or was that Jeff or was that Jeremy who asked that?
It was me. Yes,
yeah,
that
okay.
captures it.
Great. I think I missed whose hand went up first between Jeremy and Bharati.
I just wanted to mention that we bring irreproducible builds and GitBOM in the same context, and sometimes I just get confused if they are meant to be treated within the same problem space or in different problems, because there could be non-deterministic builds or irreproducible builds can come in from several sources. I could just, for example, embed a time date macro or somewhere in the source code, and every binary would be different. And of course, we have talked that I changed the compiler option, or use a different compiler. So for the same sources, 2 different build processes can generate different binaries. And that is where we discuss that, okay, we ought to capture the essential metadata, which, in combining everything, we'll be able to make more sense out of the GitBOM information. So that was the part that I wanted to say. Should we treat? Okay, the understanding is for the same source, assuming that there is no non-determinism introduced in the sources and the compiler options, etc. 2 different build process, I would imagine, should generate the same GitBOM ID is based on my current prototyping experience. And this is what I like to confirm by running the Linux build and comparing the Git documents generated using BOM-sh, which is a different process to generate the Gitoids, and the LLVM GitBOM, which has a different understanding of the same spec. Basically, it's the same spec that both the tools are referring to, but it will be good to compare notes how these two different tools interpreted the same spec and came up with this Gitoid. So I think that will be a good understanding to see if two different GitBOM generation tools, how much they are able to converge in what they generate. Does this make sense?
I didn't count that in the notes, but I think it made sense.
Okay.
We are almost at time. Jeremy, are your comments pretty quick?
So I just wanted to comment on the provenance question. Like GitBOM is very much focused at a very fine-grained, like each individual artifact, and it doesn't represent provenance in terms that an organization might represent. Like, you know, we don't talk about OpenSSH version 1, 2, 3, 4. We're talking about the hash of this particular file that may or may not be part of OpenSSH. And we don't represent packages or organizational structures that way at all within GitBOM. So the question of what you can actually use GitBOM to represent is scoped by that. So you could say, oh, we have the CV against this version of OpenSSH, and we have this big list of all the hashes of sources in OpenSSH, and we can find all of the GitBOMs that reference those sources by identity, and therefore may or may not be subject to the CVE. The question of convergence is kind of really interesting in this context, because you can look at two sets of inputs and that happen to produce the same output, and you can find the intersection between those inputs and decide that anything that's not in that intersection must not be related to producing that output and therefore is not relevant. And so baking in the BOM IDs into output prevents that kind of analysis, because it produces it prevents convergence where convergence might otherwise happen.
I don't think that's. It depends on which parts of convergence you care about. So if the things you care about are the intersections of the leave files, then you're still fine. If the things you care about are the total intersections, the DAG, then you're probably correct. In other words, I might have a situation where but I don't think your statement is. I think your statement is in the direction of something that's true, but I don't think it's 100% as strong as you made it.
Well, it's completely true in the current spec because of the thingy principle we were just talking about before.
The thingy principle.
I forget the name, but I mean, basically, I'm trying to rush in a fairly subtle, complex point in the last minute of the meeting, which is not really reasonable. So maybe we should continue on this next week.
Okay. Pulling in a thread from the side chat, it sounds like a couple of folks have asked to have someone from the IETF RATS, Remote Attestation Proceedings Working Group, come give a presentation here on attestation. I have been too deep in that work to know how valuable it would or wouldn't be to others. But I think the best person to give that would either be Eric Voigt or Frank Burkholz. Hank Burkholz, there we go. Yeah. Because it's specifically not just the hardware side of it, but how we're thinking about signing and artifact provenance is very integral to how GitBOM could fit into the puzzle pieces of something like SigStore or other attestation paradigms that are out there and being built right now. So who wants to coordinate that with either Hank or Eric? Anybody want to put their hand up, or am I going to do it?
I can do it. I know he's participating in some of the SPDX work as well.
Great. Thank you, Jeff. Awesome. Thank you all for a great meeting. See you next week or the week after.